Welcome to our mobility presentation. I'm Josh.
I'm Alex.
I'm Ethan.
And I'm Oscar, and we're going to run you through our ideas and solutions to help improve mobility on campus. Our group number is group number 6, and our team name is group 7.
Purdue University has tasked us with creating a universally acceptable mobility solution to increase safety and traffic flow in the Academy Park area. This solution needs to be inclusive of people using all types of transportation solutions, including walkers, bikers, and skateboarders, and should be inclusive of people with disabilities. As engineers, civilian safety is our number one concern. Therefore, creating a mobility solution to increase safety and accessibility is especially important.
The initial phase of ideas involved multiple different functions that needed to be met. We knew that we needed to focus on a problem with mobility in the Academy Park area. We looked at many different already existing solutions to the problems to get some basic ideas about different problems.
We examined 3 already existing designs that complemented some of our initial ideas and used them to help us formulate our design ideas and prototypes. The first piece of prior art was a pedestrian crossing sign with lights. This was a big inspiration for our idea to create a button-activated light to alert vehicles that a pedestrian was waiting to cross. Next, we have a design for a bridge. One of our earliest ideas was to create a pedestrian bridge over the clapping circle, but we later scrapped it after realizing how difficult it would be to implement. Finally, our last piece of prior art was a speed bump design that we used to help us design our first prototype. To attack the problems that arose, we designed 3 unique prototypes. Our first design was a speed bump that would be placed into bike lanes to ensure bikers and skateboarders slow down in heavy pedestrian areas. This would protect pedestrians from anyone going too quick on a personal vehicle. Slowing down bikers and skateboarders would ensure that they had adequate time to come to a complete stop if a pedestrian were crossing the bike path or street in front of them.
Design was a unique stop sign directed at bikes that would be placed at pedestrian bike path intersections to ensure bikes came to a complete stop for any pedestrians that needed to cross the path. This new sign would also be especially useful in high traffic areas where there may not be a lot of opportunities for pedestrians to get across.
Our last design idea was a blinking light with a buzzer that was button activated. The concept behind this was a pedestrian would come to a crosswalk over a street or bike path and hit a button that would activate a light attached to the pole. The light would blink and have a buzzer sound associated with every blink to alert anyone in or on a vehicle that a pedestrian was waiting to cross, allowing plenty of time for safe crossing.
To test these prototypes, we had to collect data on their effectiveness. To test the speed bump, we used a scale model made of cardboard in an RC car. We used the car to determine how much a vehicle would have to slow down to cross a speed bump without losing stability. After several trials across the entire range of the car's speed, we determined that the only way to cross a speed bump without causing instability is by coming to a complete stop, which would be too inconvenient for mobility.
To test the stop sign, we made a physical design that we sent out in a survey to find out how people would react to it. The survey resulted in high confidence in safety with the sign present, but there was some confusion on whether the sign was for pedestrians or bikes to stop. Much like the last design, this one would also require a complete stop every time a bike or skateboard traveled through.
We also had a system of lights and buzzers that would blink and beep when pedestrians wanted to cross and tested it with another survey that got similar results. This design also seemed to cause less confusion among pedestrians and bikers alike. After 100 trials of testing our Arduino model, we found that the lights were very consistent and viable for this use.
To help weigh all these ideas, we created a weighted decision matrix to help us understand how these ideas fit with our criteria and constraints. Within our decision matrix, we weighed our criteria and constraints in order of importance and graded our solutions based on how well they fit these constraints based on expected metrics.
Solution, we decided to combine our 2 best ideas into one. We took the buzzer with lights and put it on a visible sign. There's a button on the sign so that when you press it, lights and a buzzer start to bring attention to the sign. This will help with the visibility of the sign and make it more effective. This solution is relatively cheap addition to already reasonably priced signs and comes with a lot of improvements. This type of sign would be a great addition to the Academy Park area, especially in high conflict areas between bikers and walking pedestrians.